Hey guys, so we're on to 11.9, which is the last section of this chapter, and it is about similar solids. So a similar solid is they're two solids of the same type, which means that they're either two cylinders, two spheres, two prisms, two pyramids, etc., with equal ratios of corresponding linear measures. Okay. Give me a second to write this down. Alright, and so the similar solids theorem states that if two similar solids have a scale factor of AB, then the corresponding areas have a ratio of A squared B, I'm sorry, that should be A squared B squared, not B cubed right here. Let me actually fix that. Alright, so the corresponding areas have a ratio of A squared B squared, and the corresponding volumes have a ratio of A cubed B cubed. Okay. So, for example, if the scale factor of a solid is 2, 1, what is the ratio of the area? It's going to be 2 squared, 1 squared, so it's 4, 1. And then the volume is going to be 2 cubed and 1 cubed, which is going to be 8 and 1. Alright, so here's an example of some of the problems will either, they'll ask you to state whether or not the two different solids are similar, and so that's what we're doing here. So these are both rectangular prisms, and then so you want to find the ratio of the corresponding sides. So the way you do that is, alright, so you got 3 and 6, so the ratio from is 3 over 6, which equals 1/2. Okay. Sorry, my notepad is still messed up, so I'm just using the mouse and it's not working great, but so 3 over 6, and then you do 4 and 8, which the ratio between those sides is also 1/2. And then the last one is 6 over 12, which as you can see is also going to be 1/2. So since the ratio of the corresponding sides are all 1/2, then these are similar rectangular prisms. And you have to make sure that every single one is going to be the same ratio. So these first two with 3, 6 is 1/2, 4, 8 is 1/2. But if that stays 6 and this was 13, for example, then the ratio for this last one would be 6 over 13, which isn't the same as 1/2. So it would not be similar if this side length was anything but 12. So it has to be all three of them have to be the same ratio. So I mean, that's pretty much it for figuring out if they're similar or not. So yeah, sorry about that. There's somebody. It sounds like a train or something. I have no idea. But so yeah, for prisms, you're going to need to find the length, the width, and the height. For a cylinder, you're just going to need to find the radius and the height when you're comparing cylinders. So, I mean, you'll see with the examples, but this is the gist of it, just comparing the corresponding sides to see if the ratios are the same. And then there's some of them that use the theorem that I put in the notes about how if they are similar, the ratio for the volume is going to be cubed, and for area is going to be squared. So there's some problems dealing with that, but I think that's pretty straightforward using the theorem. So so yeah, that's it. The bell's about to ring, so I don't have time to come up with any sort of facts. So all right, thanks guys. See ya.